Hi, and welcome to Supernatural by Design. I hope everyone's had a blessed week. If you're new here, be sure to hit the like and subscribe button so you can receive all the latest content. And if you're returning, then welcome back. Today's topic is going to be a fun one, and will be on the authenticity of God's fingerprint in nature using the number 11. You see, God's fingerprint can be found in the number 11 because the number 11 is the backbone behind all the things that we can see, touch, and hear. And what do I mean by that? Well, the number 11 underscores all of mathematics and underlines the very scientific equations that describe our physical reality. Whether it be in nature, music, the cosmos, or even down into the quantum realm, there is a unique pattern about 11 there. The question is, why? In this particular video, we will uncover why 11 is important to us. We will discover that the number 11 creates an inherent pattern within all numbers, revealing a unique square pattern of geometry that is not only symmetrical, but fractal. And we will investigate a particular famous fractal called the Fibonacci sequence, and we will find that the number 11 is related there as well. However, in order to see this truly amazing connection between Jesus and his unique fingerprint of 11 within the physical universe, we need a quick foundation on the number 11. So let's begin. To understand the number 11, we need to start with the number line system. And what do I mean by that? Well, a line of infinite points that correspond to real numbers according to their distance in a positive or negative direction from a point, taken as 0, which simply means a line that contains all numbers in numerical order. However, because this particular number line pattern has various subtopics, we will only look at two, image and numbers, which will help us to pin down what 11 truly means with regards to God's unique fingerprint within nature. So let's start with our first subtopic, which is the concept of an image. Because in the Bible, it is a very important one. In fact, it is what makes us unique and special to God, because all people were created in the image of God, as found in Genesis. And according to 1 Corinthians, being in the image of God is a reflection of God's glory, as if God stood in front of a mirror and his reflection created an image of himself, like as we find with Adam. And it's the word use, image, being similar to an image in a mirror, that we get our first clue about our physical reality. Because it's interesting to note that Paul uses this exact same imagery with contrasting the physical and spiritual dimensions. And it's this idea that will ultimately begin us on our journey in unraveling the number 11 pattern found within numbers. So let's begin our second subtopic, numbers, because it too is an important concept in the Bible, because numbers are found everywhere in the Bible, like the number 7, 12, 40. There's even a book of Numbers. Another interesting example is the number of the beast, because that particular example highlights the use of numbers and validating that they are important. However, are these two concepts related between an image and numbers? Well, to draw that connection, let's begin with a metaphor, using an image and a mirror. So let's imagine a mirror with a 1 placed here. It would create a reflection, resulting in the image of a 1. Similarly, if we start on the number line, 11 is the first numerical number along the number line to have repeating digits or reflecting digits, and can be further demonstrated when we place a mirror here in the middle of 11. We could say that 1 reflects 1, whereas 10 or 12 don't, because 1 doesn't reflect 0, nor does 1 reflect 2, and so on, hinting at the fact that the number 11 represents reflection. Another important thing to mention is that not only does reflection create an image, but that the image is symmetrical. And what is fascinating is that the number 11 will act in the same way as a mirror, creating a symmetrical image between all other numbers. This can be amazingly demonstrated by this 10 by 10 chart, representing all 2-digit numbers from 0 to 99 in numerical order. And if you notice, the numbers going down diagonally are numbers that are divisible by 11, starting with 11, 22, 33, 44, and so forth. And if you notice, it acts as our axis of symmetry between the rest of the numbers. For example, let's look at the 34-43 branch. As we follow it out, we have 25 and 52, 16 and 61. Lastly, we have 7, which is symmetrical to 70. This particular example is similar to the 45-54 branch, and subsequently all other branches follow this exact same relationship, demonstrating that the number 11 is literally a number of reflection, creating a symmetry between the numbers that branch off of it. And lastly, another unique connection to the number 11 can be found between each symmetrical pair when added together, because the sum of any two of these numbers is divisible by 11 as well. So let's go back to our first branch that we used in our first example and see the connection. Because 34 plus 43, 25 plus 52, 16 plus 61, and 7 plus 70 all equal 77. And 77 is divisible by 11, which is also shared between all other symmetrical pairs as well, like 58 and 85. When you add those two together, 143. Divide that by 11, 13. So now that we see that the number 11 represents reflection, like as in symmetry, we now need to identify one other characteristic about the 11 pattern, and that is a square. In fact, you can derive an equation that forms the square around each symmetrical pair, as you can see on the screen, which can be found by subtracting the two symmetrical numbers and plugging them into this equation, resulting in the size of the square, as you can see in this example. So now that we know that the number 11 has a connection to symmetry, whereas the number 9 uniquely represents the square aspect, because mathematically the number 9 is 3 squared. In addition, it's in the equation that gives you the square of the symmetrical pair, highlighting the squaring of a number, because as we will see later, the squaring of a number is a fractal. In fact, both concepts, that of symmetry and the squaring of numbers, are actually both related to fractals, which we will see in a moment, because we will discover that fractals are found all over in nature, in music, art, even architecture, as well as medicine and many others, which will be mind-blowing to think about and to really see and understand how the universe is arguably made up of geometric shapes, in addition to the fact that the shape of a square, geometrically, has a unique relationship between many scientific properties in physics, chemistry, astronomy, and many other scientific disciplines. And this is all uniquely found through the symmetry created by the number 11. So come, let's expand on this topic of the number 11 and travel to the fractal world of our reality. However, let's recap. So far, we have learned that the number 11 represents a reflection, and that this unique trait is found throughout all numbers. Secondly, that there's a unique square pattern found within the reflection between all numbers. And coming up next in the video, we will see how the square shape is uniquely tied to fractals in a few short videos, because fractals are found throughout nature. And lastly, we will explore a specific fractal, the Fibonacci sequence, because it is there that we will tie back the idea of the number 11 with its connection to people being created in the image of God. So, what is a fractal?
You can find it in the rainforest, on the frontiers of medical research, in the movies, and it's all over the world of wireless communications. One of nature's biggest design secrets has finally been revealed.
My God, of course, it's obvious.
It's an odd-looking shape you may never have heard of, but it's everywhere around you, the jagged repeating form called a fractal.
They're all over in biology. They're solutions that natural selection has come up with over and over and over again.
Fractals are in our lungs, kidneys, and blood vessels.
Flowers, plants, weather systems, the rhythms of the heart, the very essences of life.
'78, I ran into this book in a bookstore. Fractals form chance and dimension by Benoit Mandelbrot, and it has to do with the fractal geometry of nature. So I bought the book and took it home and read it. Cover to cover, every last little word, including footnotes and references, twice.
In his book, Mandelbrot said that many forms in nature can be described mathematically as fractals, a word he invented to define shapes that look jagged and broken. He said that you can create a fractal by taking a smooth-looking shape and breaking it into pieces over and over again. Carpenter decided he'd try doing that on his computer.
Within 3 days, I was producing pictures of mountains on my computer at work. The method is dead simple. You start with a landscape made out of very rough triangles, big ones. And then for each triangle, break it into 4 triangles. And then do that again, then again and again and again and again.
Endless repetition, what mathematicians call iteration. It's one of the keys to fractal geometry.
The pictures were stunning. They were just totally stunning. No one has ever seen anything like this. And I just opened a whole new door to the new world of making pictures. And it got the computer graphics community excited about fractals because suddenly they were easy to do. And so people started doing them all over the place.
As someone who's been working with fractals for 20 years, I'm not going to tell you fractals are cool. I'm going to tell you fractals are useful. And that's what's important to me.
In the 1990s, a Boston radio astronomer named Nathan Cohen used fractal mathematics to make a technological breakthrough in electronic communication. Cohen had a hobby. He was a ham radio operator, but his landlord had a rule against rigging antennas on the building.
I was at an astronomy conference in Hungary, and Dr. Mandelbrot was giving a talk about the large-scale structure of the universe and reporting how using fractals was a very good way of understanding that kind of structure, which really wowed the entire group of astronomers. He showed several different fractals that I, in my own mind, looked at and said, oh, wouldn't it be funny if you made an antenna out of that shape? I wonder what it would do.
One of the first designs he tried was inspired by one of the 19th century monsters, the snowflake of Helga von Koch.
I thought back to the lecture and said, well, I've got a piece of wire. What happens if I bend it? After I bent the wire, I hooked it up to the cable and my ham radio, and I was quite surprised to see that it worked the first time out of the box. It worked very well. And I discovered that, much of a surprise to me, that I could actually make the antenna much smaller using the fractal design. So it was, frankly, an interesting way to beat a bad rap with the landlord.
Cohen's experiments soon led him to another discovery. Using a fractal design not only made antennas smaller, but enabled them to receive a much wider range of frequencies.
Using fractals, experimentally, I came up with a very wideband antenna, and then I worked backwards and said, why is it working this way? What is it about nature that requires you to use the fractal to get there? The result of that work was a mathematical theorem that showed if you want to get something that works as an antenna over a very wide range of frequencies, you need to have self-similarity. It has to be fractal in its shape to make it work. Now, that was an exact solution. It wasn't like, oh, here's a way of doing it, and there's a lot of other ways of doing it. It turned out mathematically, we were able to demonstrate that was the only technique you could use to get there.
Creation testifies of a creator, and the beauty behind it is described in the form of mathematics, because mathematics is one form of God's wisdom, as seen within fractals, by reducing seemingly complex systems into simple shapes and geometric patterns. However, how does this tie into our number line pattern? Well, if you remember, we discovered that squaring a number is a fractal. And because squaring a number is intertwined with our 11 pattern, we therefore know that the number line pattern is a fractal as well. However, what makes squaring a number a fractal? And why is this important? Well, squaring a number is actually a geometric question, and not just the product of two numbers. In fact, it's the square shape that defines the squaring operation of a number, and is an important principle of relating shapes to relationships in science and nature. For clarity, check this out.
Taking the square of something is an ancient procedure. If you say a garden is 4 square, you mean that it might be built up by 4 slabs along one edge and 4 along the other. So the total number of paving slabs is 4 times 4, 16. If the garden is 8 square, 8 by 8, well, 8 squared is 64. It'll have 64 slabs in it. This huge multiplication, this building up by squares, is something you find in nature all the time.
Before that, suddenly I fell in love with mathematics, and not mathematics in general, with the geometry in its most concrete, sensual form. That part of geometry in which mathematics and the eye meet. The professor was talking about algebra, but I began to see in my mind geometric pictures which fitted this algebra. And once you see these pictures, the answers become obvious. So I discovered something which I had no clue before, that I knew how to transform in my mind instantly the formulas into pictures.
You see, Mandelbrot discovered the fractal, and it's interesting to note that he viewed all mathematics as shapes, just as you have seen in the video. And it's from this idea that he would eventually discover this particular famous fractal, which is amazing as you zoom in, because the fractal goes on forever and continuously repeating the same pattern. What is interesting to note is that this shape is described by this equation when you iterate it over and over again. And if you notice, it's a square function. In fact, a unique application of the squaring function is found within all animals, trees, and living things.
West, Brown, and Enquist announced their controversial theory that fractals hold the key to the mysterious relationship between mass and energy use in animals. Why big animals use energy more efficiently than little ones? That's a question that fascinates biologists James Brown and Brian Enquist and physicist Jeffrey West.
There is an extraordinary economy of scale as you increase in size.
An elephant, for example, is 200,000 times heavier than a mouse, but uses only about 10,000 times more energy in the form of calories it consumes.
The bigger you are, you actually need less energy per gram of tissue to stay alive. That is an amazing fact.
And even more amazing is the fact that this relationship between the mass and energy use of any living thing is governed by a strict mathematical formula.
So far as we know, that law is universal, or almost universal, across all of life. So it operates from the tiniest bacteria to whales and sequoia trees.
And if we analyze this equation, as you can see, the mass being raised to the 3/4 power begins as a squaring function. However, a whole list of functions that we find in science can be listed out here. And as you can see, we have a wide range of equations, from Ohm's law, gravity, and the most fascinating, E = mc squared, which describes a connection between all things, from the scale of the very small, like atomic particles, all the way to the largest scale, with supernovas and galaxies. Therefore, there is a unique connection about the shape of a square and the physical properties of nature. And interestingly enough, the squaring function could also be called the triangle function, because it works just the same, in that if you have 3 triangles, then it would take a total of 9 triangles to complete the triangle. In addition, having it in this shape, you actually gain some information that you don't from the square function, in that you have up triangles versus down triangles. And the connection between the square and the triangle is even alluded to in Pascal's triangle, which we will get into later. Lastly, it is interesting to note that the shape of a square is referenced in some unique places in the Bible, within the Holy of Holies in the Temple of Jerusalem, as well as the New Jerusalem that comes down from heaven. And both are described as cubes, which is the 3D version of the square function. Because if you had 3 cubes lined up, then completing the cube would be 27. Therefore, the square is a fascinating shape, and we have discovered it in some unique locations. From the 11 number line pattern, which created symmetry between reflecting digits, to the foundations of fractals, which is underlined by geometric shapes, like that of the square. And the square itself, when you apply it to mathematics, when you square a number, it's even related to the physical properties in science, nature, and animals. And because we know it plays a major role in the construction of biblical architecture, we can say that squares play a unique role in a wide variety of topics. In fact, it plays an interesting role in one of the most well-documented fractals in science, the Fibonacci sequence. Because it's through the Fibonacci sequence we will see the connection to the designer behind the universe, and will ultimately bring us full circle back to the number 11, highlighting our unique relationship to Jesus. So come, let's explore the Fibonacci sequence and its unique connection to the number 11.
Now, I want to show you something. We always talk about randomness. The universe came about by randomness. That's the whole premise of evolution, right? How many of you have ever seen randomness? Besides at Las Vegas, okay? As you look at randomness, and the intent here was to assemble random bits. And by the way, that turns out to be very difficult to do. In a computer, you can't get randomness. They have pseudo-random number generators that generate a string of numbers that meet as many tests as they can conceive of for randomness, but they're still not really random. But I want you to look at these treat these as random numbers. Do you notice what's missing? There's something missing here. Can you spot what's missing? Randomness lacks symmetry. Do you ever see random things symmetrical? See, the very concept of symmetry implies order. A center line on a drawing implies that there's an architect around. That's how they discovered all kinds of things about the architecture of the Temple Mount, because these things all line up on a center line. That has profound implications. You notice randomness lacks periodicity. Every third one doing something or whatever. There's no periodicity. In fact, that's one of the tests of randomness. If there's any periodicity, it fails the test of randomness. You know what I mean by periodicity? It has a cycle, okay? Randomness lacks any evidence of design by definition. Because if there's design, that implies it's no longer random. Randomness lacks order of any kind. That's why the scientists, as they search for extraterrestrial life, listen to the noise, the randomness, in the hopes of finding some kind of order. And what they rule out, of course, if it's periodic, every second or something, it could be generated by some natural phenomenon. So periodicity doesn't, they're not looking for that. But they're looking for any evidence of design. That's why random numbers are a typical conjecture. If you're trying to communicate to another alien culture, a series of random numbers is one of the ways to get their attention, presumably, because how would you generate that? Well, I got a surprise for you, because there is a sequence of numbers that, how many of you have heard of the Fibonacci numbers? There's how many? There's 1, 2, 3, anybody else? Okay, it's interesting. I have heard about these since I was a kid. I never took them seriously. And because they are the domain of some pretty strange characters. But back in the 12th century, Leonardo Fibonacci, he was messing around trying to predict rabbit populations. And he discovered a series of numbers that bears his name. And the first, it's 1, 1, then 2. Each number is the sum of the previous 2. Third number is 2, the next number is 3, which is 1 plus 2, then 3 is 2 plus 3 is 5, 5 plus 3 is 8, 5 and 8 are 13, 8 and 13 are 21. See, each number is the sum of the previous 2. You follow me? That is the Fibonacci sequence. The mathematician, he first discovered it in the 12th century, but he didn't recognize the real significance. It took several hundred years for people to discover that this sequence appears in nature in some of the strangest places. The ratio of any two adjacent numbers is approximately 1.6. It varies a little bit in the second and third decimal place, but it's very close to that. And now, it was several hundred years before the significance of the sequence is recognized. There is a sequence, it shows up in what's sometimes called the golden rectangle. The ancient Greeks seem to discover that there's a rectangle whose proportions are the most pleasing. And they call that the golden rectangle. That's when the longer side is the shorter side, as the shorter side is the sum of the two sides. And that's a rectangle of a certain proportion. It's on the screen right now. That rectangle is called by artists and scientists and mathematicians as the golden rectangle. And it has some peculiar characteristics. The ratio of the short side to the long side is 1.618 of the short side. But the point is, if you take a square out of that, you still end up with a golden rectangle. If you take a square out of that, you end up with a golden rectangle, and so forth. You follow me? It's got some interesting mathematical properties, and on it goes. Okay. It turns out the Parthenon in Greece, the Great Pyramid, the United Nations building, your credit cards, your playing cards, postcards, the switch on your light switch at home, writing pads, 3x5 cards, 5x8 cards, all of these are based on the golden rectangle, whether you realize it or not, okay? In art, Leonardo da Vinci, Van Gogh, Vermeer, John Singer Sargent, Monet, Whistler, Renoir, many artists recognized that by building their art on that golden rectangle, it gave it vitality and movement. And it was the dynamic, what they call dynamic symmetry, in contrast to static symmetry. So it implies growth, power, movement, and gives animation, and so forth. And the artists have discovered that, and if you're a student of art, you're well acquainted with this. In floral arrangements, we discover the lily has 3 petals, the yellow violet 5, delphinium 8, the mayweed 13, the aster 21, perithum has 34, helenium has 55, Michaelmas daisy has 89. So if you're one of these people, she loves me not, if you know the Fibonacci numbers, you got a chance of winning that one. Okay. All these, of course, are in the Fibonacci sequence. There's a study among scientists called phyllotaxis, and that's where you study the arrangement of leaves around the stem of a plant. Visualize taking a plant and taking a cross-section and seeing how the leaves are ordered in the plant. It turns out the elm always has 1/2 the circumference, the beech or the hazel has 1/3, the apricot and the oak have 2 every 5, the pear, the poplar has 3/8. Each one of these, the almond, the pussy willow, pine trees are always 5 to 21 or 13 to 34. These are all Fibonacci numbers. Now, first of all, they discovered this, and that was bizarre because you'll never find a number that's not in the Fibonacci sequence, which is weird. Out of 434 angiosperm and 44 gymnosperms, they all have Fibonacci numbers in their design. And scientists have discovered that maximizes the exposure to sunlight and air without shading or crowding from the other leaves. Depends on the nature of the leaves. So this is a result of very skillful design, but the design is motivated in part by beauty. And there's a whole other thing, I didn't get a chance to do this. You go down, if you're a diver, you know if you go down 60, 90 feet or so, it starts getting bluer and bluer, pretty dark. You go down deep enough where it's dark and turn on a light, things are incredibly colorful. Why? Nobody can see them. Why are they created in the first place? For His pleasure. We have a God that loves beauty. A whole other thing I get into here, as you drive and see scenery, you never see it monotonous, except unless you're going through Kansas. Yeah. As I was driving in here thinking about this talk, as you go drive a mountain road, we drive through a mountain road, and there's all these trees. The trees are random, and yet they're not monotonous. The design of the trees are not predictable. Each one's different, and yet conforms to a motif. It's astonishing how you can look through nature and never see monotony. It's always got the strange variety. So about seeds. The rows of bracts on pine cones, it's 8 or 13. There's 2 rows. On pineapples, there's 3 rows. It's 8, 13, and 21. And it turns out there's an optimum divergence angle of 137.5, which is, in effect, a fraction of the 360. That's a Fibonacci number. It produces the best packing. And that's why you always see Fibonacci spirals on sunflower. If you look at sunflower, you've got 2 divergent spirals. They're both Fibonacci numbers. And let's talk about music. How many play music in here? Okay, you've got 5 keys that are the pentatonic scale, right? You've got 8 that are called the diatonic scale. Those are Fibonacci numbers. You put them both together, you've got a chromatic scale, 8 and 5 together. A major sixth, which is considered, for strange reasons, beautiful, is a ratio of frequencies. That's 3 to 5. And a minor sixth is, again, a ratio of... These are all Fibonacci numbers, all through music. For some reason, it works. You hit 2 keys, some of them work, some don't. If you're a musician, you know why. But part of the reason is you got Fibonacci numbers undergirding that whole analysis. But here's the one that blew me away. I was reading up on this and I thought, that's kind of weird. If you look at the revolution of the planets in our solar system, you got Neptune. Pluto is a problem for a number of people. I won't get into that here. But you got Neptune, Uranus, Saturn, Jupiter, the asteroid belt, Mars, Earth, and Venus, and Mercury. If you adjust the observed orbits just slightly to what I'll call here the theoretical orbits, each one is a Fibonacci ratio to the previous one. And you say, Pluto is too, but in an inverse way, because it's 90,000 miles against Neptune's 60,000, so that's a 3 to 2 thing. But I want to stay out of that for some other reasons. Pluto is a whole other issue. Anyway, the point is, what's interesting, these are the same ratios that you find in the elm, the beech, the apricot, the pear, the almond, the elm, the pine, and 3 different pine numbers. You say, what on earth does the trees have to do with the design of the solar system? Very simple. The same guy did both of them. The same guy had an insight of what makes things beautiful. That beauty is an elusive concept on the one hand, and yet we discover there's certain rules even in design that we find. Let's just take one more. If we take the golden rectangle, take a square out of it, take another square out of it, take another square out of it, we have, with the golden rectangle, we can create a spiral, right? Very famous spiral, it turns out. It's the only spiral that does not alter its shape as it grows. It has that peculiar mathematical property. And you've all seen one in what's called the chambered nautilus shell. It shows up a lot of other places too, but I mentioned this is just a very crisp example. You find that in the hurricane, spiral seeds, the ram's horn, the tail of a seahorse, fern leaves, the DNA molecule. You'll find it in waves breaking on a beach, tornadoes, galaxies, the tail of a comet around the sun, whirlpools, seed patterns of sunflowers, daisies, and dandelions, the ears of all mammals, and especially the cochlea of the human ear. You have one in your ear that helps convert the sound vibrations into pulses that the ear can transmit to the brain. We'll talk a little bit more about that as we go. You remember Da Vinci's famous anatomical sketch of man, and you take from the navel to his feet, and you discover it's a golden rectangle relation. If you know that distance, you know how tall he is by applying the golden rectangle. And you can do that from his navel to his chin. You'll find the length of his face, from his chin to his lips, the tip to the nose to the pupils to the top of his head, and so forth. All these yield the distances of various parts. You'll discover the golden relationships are all through his basic design. And since man is in the image of God, in some sense, it's not surprising to find out he apparently has what we understand to be mathematically harmonious proportions. And we find it all through nature, even whether you're talking about seeds in a plant or the orbits of the planets.
Since the Fibonacci sequence has been described as the ideal proportions to define beauty, and remembering that the number 11 represents a specialness to God because we are created in His image, is there a relationship between both? We will see that in fact they are related in one particular way, as well as some other subtle ways that we find within the sequence. And here are 4 examples. 1. If we start with the number sequence 0, 1, 1, 2, and 3, and so on, then it would make the 1s the only repeating digits by virtue of the function itself, which is interesting, but let's keep going. Secondly, from the number line graph, the numbers divisible by 11 represented the center line, forming the symmetrical pattern, which created squares around it. Well, a similar setup can be found in the Fibonacci sequence, because the 1s are at the center as well, with squares around them, which is also interesting, but let's keep going. Thirdly, they are both in your hands. 11 is in the symmetry between your fingers, and the Fibonacci sequence is in the lengths of your fingers. Lastly, and my most favorite example, is the relationship between the Fibonacci sequence, and Pascal's triangle. And for those that aren't aware of what Pascal's triangle is, it is just another number sequence derived from the shape of using a triangle and placing ones on the outside like this. You then add the numbers from the previous two terms above to produce the result below. And you repeat this, filling out the rest of the triangles. And this is actually useful in determining the coefficients of polynomials as they grow exponentially. Surprisingly, Pascal's triangle is also related to prime numbers, but we will get into that aspect of Pascal's triangle in another video. However, it's the relationship between the Fibonacci sequence and Pascal's triangle that we want to go into detail about. Because if you lay out Pascal's triangle in this fashion, the diagonals as you add them are Fibonacci sequence numbers, just as you see on the screen. And so how does the number 11 come into all this? Well, check this out. If you take 11 to the 0th power, well, that equals 1. Take 11 to the 1st power, you get 11. 11 to the 2nd power, 121. And 11 to the 3rd power, 1331. 11 raised to the 4th power is 14,641. Whereas 11 raised to the 5th power is 161,051. Which is similar to the line in Pascal's triangle, but it starts to change a little bit, which it's my belief that what is happening here is there's something fractally changing, however, still uniquely tied to the number 11. And so as you can see, Pascal's triangle highlights symmetrical pairs, just as what we saw with the number line pattern. And ultimately, the number 11 is connected to Fibonacci sequence through Pascal's triangle, which is an incredible fact. In conclusion, the Fibonacci sequence is a unique number pattern that is found within nature, the human body, and the number 11. And since we know the number 11 stands for symmetry or reflection about an image, and being that we are created in the image of God, has God used the simple concept of the number 11 as a unique identifier uncovering our special relationship to Him and to our physical universe, as we have seen throughout this video? The answer is yes, and even more so as believers, because according to Romans 8:29, we all have the same form as the image of the Son of God, highlighting once again the importance of an image and tying it to save believers, for those that are children of God. As for our physical world, Colossians 1:15-16 states again that Christ is the image. However, it tells us that Christ has created the visible and the invisible, and that all things were created through Him, which would demonstrate Christ as the mirror, because the spiritual world would be the one outside of the mirror, whereas the physical world would be the one symmetrical that is within the mirror. And both were created through Christ, being the center point, reflecting the spiritual world to the physical, and that this relationship can be demonstrated through mathematics, and in particular squares and fractals, creating geometric shapes that are symmetrical, like that of the number line 11 pattern. And so ultimately, the number 11 represents our unique relationship to God, spiritually, physically, in mathematics, whereas other videos we have seen that the number 11 is used in significant dates, biblical prophecy, the entertainment industry, Bible codes, famous people, and many other unique places. And all these instances always point back to Jesus. Well, this is where we will end it. I thank you for watching, and please make sure you hit the like, share, and subscribe button to receive all the latest content. Thank you, and have a blessed night.